Here, cosine 2x is being replaced with that 1 over 5. So now we replace that with 1 over 5. Let me go back because I'm just going to keep that in red. Everything else will stay in that black. Cosine squared x minus 1. We should think of this. Don't overcomplicate this. This is just 2x squared minus 1. That's it. Solve for x. That means you're adding 1, dividing by 2, and then you're taking a square root to finish that off. All right, so when I add 1, we add 1 to this side. That'll cancel out. But on the other side, I'm really picturing adding 5 over 5, which is actually going to give us 6 over 5. Running out of room is 2 cosine squared x. Then we divide by 2, but I said sometimes it's easier for people, instead of dividing by 2, think of it as multiplying by 1/2. It's a little easier to picture a fraction being multiplied by 1/2 than a fraction being divided by 2 and having to do that keep, change, flip. So in my head, I'm picturing multiplying both sides by 1/2. Well, that will either give you a 6 over 10, or you might realize that that simplifies to 3 over 5. Equals that cosine squared x. Our job is now to take the square root of both sides. At this stage, when you take the square root, you have to realize that you have plus or minus. Well, now we're finding cosine of an angle equals something. I have to decide if it's positive or negative. So we go back up to the directions, and the unfortunate thing is they tell me what 2 times the angle is. So if I have a 100-degree angle and I multiply it by 2, it's 200 degrees. It's now in the 3rd quadrant. Well, I don't want to know what 2 times the angle is. I want to know what the original angle is. So what you're going to do is you're going to divide everything by 2 up here, which is going to result in 135, that's useful, is less than alpha is less than 180. For me, that 180 is the bigger of the 2 values. Because what I'm picturing is, okay, this angle has to be just a little bit smaller than 180. So picture where 180 is on a unicircle. It's way over here, and you're a little bit less than that. You must be in quadrant 2. So cosine alpha, at the end of the day, has to be in quadrant 2. And what is cosine when it's in quadrant 2? It's going to be negative. So our answer better be negative. So I'm going to take the negative one. So we're going to have negative square root of 3 over square root of 5 equals that cosine x. Well, that's not on the board, so we should simplify that to be cosine x equals our negative square root of 15, because we would have square root of 5 times square root of 3. If you're multiplying square roots, you just straight up do the multiplication under the radical. And that will be all over 5. And that's our finished answer. It's A. Negative square root of 15 over 5. Questions on the bell work? You can expect these on the test. And my advice is make sure you know how to do them pretty well, because that's what will save you time. Getting to this problem, me talking about it took longer than it should have taken you to just do it on your own. If I give you 5 minutes, you should have more than enough time to even make mistakes on it and still get it correct. So this should be an easy, just write down the identity, plug it in, and then straight up algebra. At most, you should lose a half point, because maybe you subtracted 1 instead of adding 1. You forgot to take the square root, something small like that algebraically. All right, if there's no questions on that, let's go over any questions from the homework that we want. Yeah, Peyton.
Number 6, the second part, like finding signs.
Yeah.
I just got completely wrong. So.
Oh, okay. So I think I just gave you cosine, right?
Yeah.
On the answer key. So let's start there. So you were okay with that cosine value being negative 7 over 8.
Actually, no, I don't know what I did wrong. I got 9/8.
Oh, okay. Let's go through the logic of this. So we know the half angle.
I did actually.
What was that?
I kept the minus.
Oh, you kept the minus, yeah.
Yeah.
The big thing about using these is that at some point we're going to clear up both fractions because for both of these we are squaring and squaring, so the negatives will drop out of both of those to give us 1 over 16 and 1 plus cosine alpha over 2. In fact, I did point out that this should be negative, but it's not important. It's not important because we're going to end up squaring both sides. It's good to think about it, because to know you're in quadrant 2, so that should be a negative value, but it ends up canceling itself out by being positive. Let me know if that doesn't help with the sign value, though. All right, other questions? There were people that said they had other questions. Yeah, Stuart.
Number 3.
Yeah. So on number 3, maybe I'll write this in. Oh no, I wrote the wrong thing. Erase that. -1. Okay, so on number 3, I actually did 2 steps in one. But I'll clarify it just a little bit. I understand the confusion of what happened there. So what I did on these, were you okay up to here? We're basically just plugging that negative 15 over 17. Now, I did 2 steps at 1. I added 1 to both sides, and I divided by 2, all in the same step. So let's show the intermediate step. So if I add 1 to both sides, if I go, okay, plus 1, boom, boom, that means over here it'd be plus 17 over 17, which this intermediate step, I'll put it in red, would actually be 2 over 17. So this would be that intermediate step if I was going step by step. Well, in order to get rid of this 2, I'd multiply both sides by 1/2 or divide by 2. Either way, we'd see that the 2's would cancel each other out, and it'll turn into 1 over 17. So I just added and divided all in the same step. I don't encourage you guys doing that. It's an easy way to make dumb mistakes on a test. I would have the intermediate step like here, but I was just doing a quick answer guide. So is that a little clearer where I came up with that? Okay, awesome. Yeah.
Still confused on
Okay.
sign part.
Then let's go back to it. All right, so we came up with cosine being -7 over 8, right?
Yeah.
Okay, so did we use...
Oh, no. Okay, never mind. I'm good.
Okay. We should know it's negative because it is alpha. And, it would have worked itself out because we would have subtracted 1 from both sides as well. Perhaps you had 1 minus cosine instead of 1 plus cosine? Yeah. Easy to confuse that up because the sign of a half angle, the only difference is this would be a negative. So if you look at the one right above it, the only difference is that would be a negative instead of a positive. Easy to confuse. Yes, Stuart.
Can you actually do the sign part for number 3? With that, I just tried solving it.
With this cosine?
Yeah.
Okay, did you use the sine squared plus cosine squared equals 1, or did you use the other method?
I used the one that you have up there.
Okay, so we have sine alpha equals a positive, and what I would do is I would not plug in the negative square root of 17 over 17. I would use this one. It's going to help you not make a dumb mistake because if you picture this squared, that's just going to be a positive 1 over 17. So if I take this and plug that in there and I square it, I'm going to have 17 over 17 minus that 1 over 17. This will turn to a positive because I'm squaring it.
Okay, I see. I accidentally squared it, so I got to 89.
Oh, okay, yep. Well, you'll still get the same answer. It's just a lot easier to keep your numbers small. You're going to make a lot less mistakes. So I highly encourage, if you're doing that method, steal this one. Don't wait for the simplified one. Because, yeah, then you have that 289 and that 17. A lot of room for mistake. All right, any more questions? Those are all good questions. It's good to see all these over and over and over. Okay, then we'll get to some verifying problems. I will tell you right now, these are verifying problems that will cause you problems, I guess. Our ones from the previous chapter that we just took a test on were basically, if you push the two fractions together, it kind of solves itself after that. We have to come up with that one big decision. These, we're going to get through it, and we're going to, at one stage, actually have to take a guess at what we have to do next. And we have to think about what happens when I guess this, what's going to happen next. And that's because if you look at your double and half angle identities, if you look at your cosine double angles, there's 3 to pick from. If you look at your tangent half angle ones, there are 3 to pick from. So when you're verifying, you're going to have to pick one of those 3 at times in order to make it work. We'll see that about the third step. So if you remember from last test, I said if you ever see like sine of alpha plus beta, that has to be the side you start on. The same thing's going to be true if you see a multiplication. I don't care how... this side looks more complicated, right? On day 1, I said pick the most complicated side, and then I said things will trump that. This will trump that. If you see a multiplication inside the parentheses, that trumps doing anything else. It's the same thing as an angle addition. So we need to start here. It has to be. If you start on the other side, you're never going to get to the end. So we're going to start there. This one's going to get pretty lengthy, so I'm not just going to draw my straight line. I'm just going to kind of write straight down. When I think I'm good, then I'll put my straight line down. All right, so sine of 3x. Let's go to our sheet and find our triple angle identity. On that gold, there isn't one. Yeah, everyone should be a little confused. We have that gold sheet that has double angles and half angle identities on there. So we don't have a triple angle identity. How can I write 3x to match something we would know? Yeah, Karen. 2x plus x. Let's just stay there. So we have sine of 2x plus x. I'm going to note that's a combination of 2 identities. The first identity is our angle plus angle. If you notice I have both gold sheets, you should probably have your other gold sheet out as well, because this is an angle addition identity. And sine of an angle plus an angle equals sine, cosine, cosine, sine. Can we all find that in our double angle or our angle addition ones? Our angle addition says, okay, if I have something plus something, I can rewrite that as sine of the first angle. I'm going to include the entire 2x. That is the entire angle here. It's that entire something. We're going to multiply that by the cosine of the second angle. In this case, it's x. If you look at your sine of an angle addition, if you're adding your angles, you add in the identity. If you remember for cosine, if it's adding, you subtract in that identity. Then we take cosine of our first angle. In this case, it's still that 2x times sine of our second angle, which is just x. So once again, I'm treating that 2x as my first angle. I'm treating that x as my second angle. Now we have to use our double angle identities, because sine of 2x we can rewrite as, and there's only one option. If you look at your double angle identities, sine of 2 times an angle just equals 2 sine x cosine x. So we're going to rewrite this. I'll change my color. We're going to rewrite this as 2 sine x cosine x. So I just replaced that. Noticing this is in parentheses, so we're going to end up multiplying that by cosine x in a second. Here's where we have a small problem. Find your cosine of 2x on your sheet. I'll take a picture of it. You at this stage have to pick one of these 3. There are going to be times where you pick wrong. But here's a guide to help you try to pick the right one. Don't just randomly pick one. What I want you to do is look at the other side. And look what needs to be created. I need to have 3 cosine squareds. Well, if we look at what we already have, we have a picture. If I multiply that cosine here, we're going to have, maybe I'll write that. We're going to have 2 sine cosine squared x plus something. Well, when I'm picturing, if you look at this 2 and this cosine squared, I'm already creating 2 cosine squareds. I'm already creating 2 cosine squareds. So I probably don't want to pick this one because that would create 2 more cosine squareds. That would create a total of 4 cosine squareds. Does that kind of make sense? So I'm just counting how many cosine squareds I have. I have 2 cosine. I know there's a sign here, but I'm hoping that sign just gets pulled out. And I'm saying I have 2 of these. I need to, at the end of the day, have 3 of them looking at that other side. All right, so maybe I won't use the 2 cosine squared one. I also need to create a sine squared, which if we look at this, this would actually be sine cubed. But I definitely have to bring at least a sine squared into this mix. So that tells me what I'm going to do with that cosine of 2x is I'm going to replace that with cosine squared x minus sine squared x. In parentheses, multiplied by that sine of x. Now, before you just continue on, my advice to you, before you finish this whole thing and find out that you picked the wrong one, is in your head, kind of picture what's going to happen. So if I picture what's going to happen, I can write this down. This has to be it, because there's only one way to write sine of 2x. This is the only thing we'd have a choice to do. So if you picture, I distribute that sine x. I have sine x cosine squared x minus, well, that's sine cubed x. In fact, what we could do here to help us picture what this should be is maybe on the right-hand side, I actually distribute that sine squared x to see what we'd end up having. So if I did that distributing, I would have 3 sine x cosine squared x minus sine cubed x. Well, if I do this multiplication, I do have my sine cubed x. That's what I want. So on the surface, it looks like I picked the right one. So let's actually do the multiplication and make sure it does turn out to be the right one. So make sure you distribute that sine x to both that cosine squared x and that sine squared x to actually give us sine x cosine squared x. And then we do sine x times sine squared x, which would be a negative sine cubed x. We're going to note that 2 sine cosine squared plus sine cosine squared is going to actually equal 3 sine cosine squared x minus sine cubed x. And that does match up with that one. Yes?
So when you say that there's 3 sine cosine squared x, is that the same thing as saying there's 3 sine x cosine squared x?
Say that one more time. There's 3.
So on the left side,
Yep.
you have 3 sine cosine squared x.
Mhm.
On the right side, you have 3 sine x cosine squared x. Is that the same thing?
Don't I have them written the same? I'm not.
It's because there's no X after this.
Oh, yeah.
Is that
Yeah.
okay? Or?
Yeah, that's okay. Yep. I don't take any points off. The only time I take off points is if there's 2 angles, if there's an alpha and beta, and you don't end up writing which is alpha and which one's beta. Yeah. I see what you mean. Yeah. So I should have had x's in both of those. I gotcha. All right. So at this stage, it's basically you have to pick one of those 3. You should try to be able to at least take an educated guess at it. My advice is, once again, picture in your head what you would result in before you write them all down. Do this in pencil, because there's a good chance you're going to mess this up and you're going to have to erase everything and go back and try it again. All right, let's do the same idea, but this time with tangent. This actually has 2 good things with where we're doing verifying with these. So the first thing I'm going to note is, yeah, I have a formula for tangent x over 2. I actually have 3 formulas we can use there. I do not have one for cotangent. So we have to realize, let's just stick with the cotangent for a second. We can always rewrite cotangent as 1 over tangent x divided by 2. How much room I need, we'll just go with that. Now, if you look at your half-angle identity sheets, we have 3 to choose from. We have that square root one. So first and foremost, do we see square roots on the other side? No. So I'm more than likely not going to pick the one with square roots. That's just my thought process is, well, that's probably not in the mix. That'll be the last one I possibly try because there's no square roots on the other side. Well, the last two have either a sign in the denominator or a sign in the numerator. What your job is to look at the right-hand side now and go, okay, 2 cosecant x can be written as 2 times what instead of cosecant? 1 over sine. So what I want us to notice is that we have that sine x in the denominator. So I want to pick versions of tangent that have signs in the denominator. So when I'm rewriting tangent of x over 2, I'm just going to say, oh, that 1 minus cosine over sine x does have a sign in the denominator. So that's the one I'm going to pick. So we're going to replace this one with that 1 minus cosine x over sine x. All right, so I just replaced that with this plus. What am I going to replace this one with? Mira?
Do you just flip the 1 minus cosine x over sine?
Well, we don't want to flip that. So I don't want to put that in there because I don't want to end up flipping it. So we have to pre-think about that. Yeah.
Just put 1 minus cosine x over sine x all over 1. So it'd be 1 and then the previous.
I got you, but we can't just put it over 1, I guess. We have another option. So think about, when I plug this in, this 1 just makes it flip it. And I want to have sine x on the bottom. If I take this one and plug it in there and flip it, I'm going to have 1 minus cosine on the bottom. But there's other ways to write this. John, are you raising your hand or are you? Carolyn?
Can you write it in terms of like cosine and sine?
No, we want to use the half-angle identities. Yeah.
Did you convert it to tangent 2x?
No. We're going to leave it as tangent of x over 2. Cozy?
Choose another one of the identities.
We're going to use another one of the identities. What identity are we going to use?
Sine x over 1 plus cosine x.
There you go. We're not going to use the 1 minus cosine x. We're going to say, oh, there's another one. So if you look at this one, if I plug that one in place and I flip that fraction, it's going to make sine in the denominator. So I am going to replace just this, because I can't replace the 1. So we're going to have 1 over, and this time we're going to have our sine x over 1 plus cosine x. So I replaced it with a different identity. And I replaced it with an identity because 1 over something tells you to flip that fraction. 1 over table is an upside down table. So we're now going to flip this fraction. That's what 1 over does. So we're now going to have 1 minus cosine x over sine x plus flip that fraction. We're going to have 1 plus cosine x over sine x. So I had to have the forethought to think, oh, this 1 is going to make me flip whatever fraction I have here. We don't want to just start rewriting tangents and stuff like that. We first want to see if there's an identity that allows me to have a sign on top that will become that bottom. Well, now we have negative cosine x. We can push those together because they have the same denominator. This negative cosine x and this positive cosine x will cancel out. Don't forget you do have a 1 and a 1 here, so that's 1 plus 1, which equals 2. 2 over sine x is close enough to that other side, and we are good. So your job is to really think about what the other side is, what's going to happen in the future. Otherwise, you really are just randomly picking one, seeing if it's working, and have to go back and try another one. We want to at least make an educated guess by trying to put signs in the denominator to try to match it up with the other side. Now note, this only occurs for cosine double angles and tangent half angles. Everything else only has one identity, so we can just write it in. For instance, back here, when we did our sine of 2x, we said, oh, we can just rewrite that as sine, or 2 sine x cosine x, because that's the only identity we have. All right, questions on anything we just did? Okay, then for the first problem on your homework, I do want to go over something really quick. It seemed to have been forgotten about in the other class. Maybe you remember this, and this is just me rehashing something. But remember the old statement that a squared minus b squared equals, who remembers what that, oh, that's tiny. Who remembers what a squared minus b squared equals? Yeah.
A plus b, a minus b.
Yeah, a plus b times a minus b. Well, I said there's going to be occurrences where we actually have like x to the fourth minus x to the fourth. You need to remember that that is still a difference of squares. You just need to think of it as being, let's not do x to the fourth, because that would just be 0. That's stupid. We'll do x to the fourth minus y to the fourth. We can rewrite this as x squared squared minus y squared squared, which makes this actually my a portion and makes this my b portion, even though it's squared, which means I can plug that x into both those a positions and that y squared into both of those b positions. And I can actually rewrite this as x squared plus y squared times x squared minus y squared. You'll need that for the very first problem. Otherwise, the rest of the time is yours to work. I will hand back tests.